In this section, we're going to talk about how we start to make things move using motors and encoders. At their most basic, motors are a way of transferring electrical energy into mechanical or kinetic energy. And encoders are a way of measuring the distance that something has traveled, either rotational distance or linear distance. There's a couple of different motor types, primarily AC and DC type motors. We're going to focus on DC motors since they're most commonly used with embedded systems. There's a couple of DC motor types. The first is called a brushed DC motor, and this is the most common type of DC motor. It uses a set of brushes that make contact with a commutator that energizes a couple of coils inside of the spinning stator or spinning rotor, and that causes a force to be exerted around these permanent magnets, and the motor rotates. The other kind of DC motor that we'll be looking at is called a brushless DC motor, and this is basically the same type of motor turned inside out. Instead of the coils on the inside, the coils are on the outside, and the permanent magnet is the rotor rather than the stator. Brushed DC motors are super common. They're very inexpensive to make. They're very cheap. It's the oldest kind of electrical motor. It's very simple construction because there's very few pieces, and we don't need them to be super precise. It's very simple to control. All we have to do is apply power and they start rotating. And they have, but the downside is that they have a low power to rate ratio. It's much harder to get a lot more torque out of them than the other kind of motor that we'll be looking at. Brushless DC motors, on the other hand, are almost exactly the opposite in their characteristics. They're often very expensive because they require a lot of precision machining. They're complex to control because we have to coordinate the firing of the coils rather than just applying power. We have to turn the coils on and off, but that gives them a high power to rate ratio. We can put as much current into the coils as we want, which gives them a lot of torque and makes them more flexible. They're also extremely precise because we can coordinate how fast the motor is running by controlling the current in the coils. We can even go down to making individual steps or control the speed of the motor very precisely. Stepper motors are a special kind of brushless motor where the stator has a bunch of different, the rotor has a variety of different magnets on it. So rather than just one or two north and south poles, there are many hundreds of north and south poles, and we have an array of coils, sometimes 2 up to 6 different coils that we can control and individually, and this allows us to lock in positions and step an individual make an individual very small step of rotation with the motor, and that gives us an immense amount of control over where the motor is and how much power it's applying. Unfortunately, it requires a really high amount of power usage because each of the coils is energized completely to its maximum current whenever it is energized, and we have to use a lot of specialized controls in order to get the high precision that we're working on here, because we have 6 coils to coordinate, and we need to coordinate that with very precise timing to get the behavior that we desire. DC motors are applied in all kinds of things. Basically, the brushed kind are applied anytime we have some kind of continuous duty. That means they're used fairly often, fairly long time, without much need for precision or speed control. So in things like the wheels of robots or pumps or appliances, stuff like that, that's where you'll find a lot of DC motors. Brushless motors show up in a lot of weird places. So like the PC fan on your computer is a brushless motor because it runs for a really long time, and we don't want the friction of the brushes to wear down and fail. So that's why we use brushless motors there. We also use brushless motors in things that have high torque demands, like the motors of drones or remote control cars, and stepper motors are used in things like 3D printers, precision manufacturing equipment, stuff like that.